This is the first video lesson for this honors chemistry class. In this class, we mainly cover Regents material with some SAT 2 concepts. Typically, I should already have taught this lesson in class already. You can use these video lessons to review the concepts at your own pace and convenience. The first unit in this course is matter. In this lesson, we'll be talking about different types of matter. Go to page 2 in the class packet. You can download the class packet from my website under Unit 1. The link will be in the descriptions. Once you download the packet, it should be a PDF file. The first page of all my packets looks similar to this. It's basically a review sheet that lists out the major concepts and objectives that you must know. So use it to study for the exam. So let's go on to page 2. On top, you can write the aim. So as we go through the PowerPoint, you are going to be taking notes by filling in the blanks. The blanks contain keywords, which I highlighted as red on the PowerPoint. So it's very easy to take notes. The second slide in all my PowerPoints looks similar to this. On top of every slide is the aim. The unit essential question is the summary question for the unit. The learning target is the focus of the lesson. It tells you what concepts you will learn by the end of the lesson. The learning target will appear at the bottom of each slide in the PowerPoint. The learning target of this lesson is at the end of the lesson, I'll be able to define different types of matter, elements, compounds, molecules, and mixtures. For announcement, homework number 1 will be a junipod based off this lesson. All fields of science can be broken down into 2 categories, macroscopic and microscopic. Macroscopic focus on things that you can see. Microscopic focus on things you cannot see. In this chemistry course, we'll be studying atoms. Even though we cannot see these atoms, we will learn about their properties and what they are. What is chemistry? Chemistry is the study of matter and its properties. Notice that this word is highlighted red. This is the word that you're going to fill in the blank in your packet. Matter is defined as anything that has mass or takes up space, which is volume. Every material in existence is made up of matter. One way is to think about chemistry as the study of stuff. Matter is basically stuff. So in chemistry, we're studying the stuff that is all around us. What is this stuff made of, and what can this stuff do? Just to recap, matter is anything that has mass and occupies space. Matter can be divided into 2 categories, either pure substances or mixtures. We will talk about what these 2 things are. In your packet, take a moment to organize these 12 things into either matter or not matter. Try to do this yourself. Pause the video. Resumes completed. Here are the answers. These 6 things are considered matter because they follow the definition. They have mass and they occupy space. These 6 things do not. Throughout all the PowerPoints, there will be learning checks. Learning checks are examples of Regents questions. They are usually based off the concepts that we just covered. Which is the correct statement? Take a moment to try to do this yourself. Resume the video once you complete it. The best answer is choice 4. Matter has mass and volume. That's the definition of matter. All matter is made of tiny particles called atoms. Keep in mind, atoms are not the smallest thing in the world, but they are the basic building blocks of matter. So in order to understand the properties of matter, we need to understand atoms. For the rest of the lesson, we're going to talk about different types of atoms and different types of matter. The first type of matter is an element. An element is one type of atom. An element can exist as either atoms or molecules. Helium is an example of an element that exists as atoms in nature. Oxygen is an example of an element that exists as molecules in nature. A molecule is a particle made of atoms joined together chemically. If we look at oxygen gas, each molecule has 2 oxygen atoms bonded together. Both helium gas and oxygen gas are considered elements because in each case, there's only one type of atom. In helium gas, there's only helium atoms. In oxygen gas, there's only oxygen atoms. Oxygen gas is considered both an element and a molecule based on the definition. Helium gas is only considered element, not a molecule. Water is considered a molecule, not an element. If you look at the diagram and the chemical formula H2O, there are two elements bonded together, hydrogen and oxygen. Since water has two types of atoms, it is not considered an element, and since those two types of atoms are bonding together, it is considered a molecule. A particle is one unit of matter, one thing. Atoms and molecules are particles. For check number 1, count the particles in each diagram. For this diagram of helium gas, there is 1, 2, 3, 4, 5, 6, 7 particles in this diagram for helium gas. For oxygen gas, this is considered one particle or one thing or one unit. So there's 1, 2, 3, 4, 5 particles of oxygen gas in this diagram. For water, this is considered one particle. So there is 1, 2, 3, 4, 5 particles of water in this diagram. Element cannot be broken down physically or chemically as a single atom. For example, helium cannot be broken down physically, and since helium gas exists as a single atom, it also cannot be broken down chemically, because atom is the smallest unit of matter. Oxygen gas is also considered an element, therefore it cannot be broken down physically. However, oxygen gas is not a single atom. It is a molecule. Therefore, it can be broken down chemically. Oxygen gas can break down into 2 oxygen atoms. Since oxygen gas is also considered a molecule, molecules can break down chemically but not physically. Water is also considered a molecule and it can break down chemically. H2O can break down into 2 hydrogen atoms and 1 oxygen atom. A catalog of elements can be found on the periodic table and Table S in your reference table. Table S gives you the full name of each element as well as some of its properties. All these elements are considered atoms and they have different properties from each other. An analogy to this will be fruits. These are all considered fruits, but they all have different properties. They all taste different or have different amount of seeds. Learning trick number 2, which substance cannot be broken down by chemical change? Try to do this yourself, pause the video, and resume as completed. The question is describing an element. To figure out which of these are element, you have to check the periodic table or Table S on your reference table. If you go to Table S, gold is considered an element. The next type of matter is a compound. A compound is 2 or more different elements chemically combined at a fixed ratio. For example, water is considered a molecule and is also considered a compound because you have 2 different elements, hydrogen and oxygen, chemically combined at a fixed ratio. The ratio between hydrogen and oxygen is 2 to 1. Every water molecule will have the same fixed ratio. That is why water is considered a compound. Table salt, NaCl, is also considered a compound because the sodium and chloride are in 1-to-1 ratio. Just like molecules, compounds can be broken down by chemical changes, but not physical changes. For example, water can break down chemically into 2 hydrogens and 1 oxygen. Table salt can also break down chemically. A compound has different properties than its component elements. For example, water molecules have different properties than hydrogen and oxygen atoms. Elements, molecules, and compounds are considered pure substances. A pure substance consists of only one substance. Pure substances have constant and definite composition and properties. For example, these bars of gold are considered a pure substance because they have constant and definite composition and properties. All these bars of gold is made up of gold atoms. Each bar of gold will have the same properties. For example, each one will have the same melting point. Another example of a pure substance will be water. Water has constant and definite composition and properties. Pure water is only made up of water molecules. In summary, elements, molecules, and compounds are considered pure substances. On the regions, if it's not stated otherwise, the word substance is assumed to be pure. Learning check number 3. A pure substance that contains more than one type of atom is called a what? Pause the video, resume is completed. In the question, more than one type of atom means different elements. Therefore, the best answer is choice 2, because a compound is a pure substance with different elements bonding. Check of understanding number 2, which are elements, molecules, or compounds. Here we're given a diagram. A represents oxygen atom, B represents oxygen gas, C represents ozone. Take a moment to figure this out. Pause the video, resume as completed. All three of these are considered elements because element is one type of atom. Oxygen gas and ozone are considered molecules because they have two or more atoms chemically joined together. Oxygen gas and ozone are considered allotropes of oxygen. Allotropes are other forms of the same element. Allos means other, and tropos means form. Forms can mean different bonding or structure. Allotropy is only for elements only, not for compounds. Another example of allotropy is carbon. Both diamond and graphite is made of a pure carbon. However, because of the different bonding and structure of the carbon in diamond and graphite, they have different properties. Diamond is hard and transparent, while graphite is not. Graphite breaks very easily. Even though graphite and diamond are made up of only carbon atoms, because of the different arrangement and structure of the carbon atoms, there are different properties. One major theme in chemistry is structure influences properties. We will see this theme throughout this course, how the structure of the atoms in a substance influences the property of that substance. Here is a concept map summarizing what we just covered. Pure substances can be divided into two categories, elements and compounds. Elements can exist as atoms or molecules. Compounds is also considered a molecule. We will discuss what ions are in the future. In your packet, highlight the 7 diatomic elements shown on the PowerPoint. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine are the diatomic elements. What does diatomic mean? Di means two, atomic refers to atoms, so diatomic means two atoms bonding together. Diatomic elements are found in pairs in nature. If we look at the chemical formula for each diatomic element, there are two atoms bonded together for each element. What does monoatomic mean? Mono means one, therefore, monatomic elements are found as a single atom in nature. Since these elements are found as a single atom, they do not bond. These are known as the noble gases, and are found on the last column on the periodic table. Highlight the monatomic elements in your packet. On the Regents exam, you have to memorize the diatomic and monatomic elements. The monatomic elements are relatively easy to memorize since they are in the last column on the periodic table. For the diatomic elements, is much more difficult. Here are some catchphrases to help you memorize the 7 diatomic elements. Have no fear of ice cold beer. I have no bright or clever friends. Help a needy class find brains immediately. Pick one of these catchphrases and use it to help you memorize the 7 diatomic elements. Learning check number 4. Which element exists as a diatomic molecule? Pause the video, resume as completed. The answer is choice 2, nitrogen. The last type of matter is mixture. Mixture is composed of two or more different substances that can be physically separated. Here's a mixture of raisin, M&Ms, and nuts. You can physically separate this mixture using your hand. In a mixture, proportion of its components can vary, and the components retain their original properties. For example, let's say you have two solutions. One solution has 5 grams of salt in 100 grams of water. The other solution has 50 grams of salt in 100 grams of water. Even though the proportion of the components are different, both are considered salt water. Because in a mixture, the ratio of the components can vary, and the components can retain their original properties. The salt and the water in the salt water retain their properties. Now that you have a basic understanding of the different types of matter, we're now going to look at a model that's used to represent the different types of matter, called a particle diagram. In order to analyze and draw a particle diagram, you need to know the rules. Here are the rules. The box is a container. Nothing gets in or out. All atoms are represented by a solid sphere. One atom is one circle. This is one particle. No squares, triangles, or stars. Different sizes and colors for each element. Here we have 3 different elements. There is an empty space between the atoms. If the atoms are touching, they are bonding. Since these 2 atoms are bonding, this is considered one particle. Even though this is a 2D model, keep in mind the particles are always moving in real life. Here we have 4 different particle diagrams. Prove that each box is showing a pure substance. Each of these boxes is showing a pure substance because only one type of matter or particle is present. For a particle diagram of a pure substance, it must show only one type of matter, such as an element, molecule, or compound. Here are 2 examples of a particle diagram of an element. Here's a monoatomic element and a diatomic element. Here's a particle diagram of a compound. Each of these particle diagrams is showing a pure substance. Check number 3. Which particle diagram represents a molecule? The particle diagram of the diatomic element and the compound represents a molecule because you have 2 atoms bonded together. Learning check number 5. Which particle diagram represents a sample of a matter that cannot be broken down by chemical means? Pause the video. Resume is completed. The question is describing an element, so the best answer is choice 4. Choice 4 is showing an element, only one type of atom. Learning check number 6. Which particle diagram represents a sample of one compound only? Pause the video. Resume is completed. The best answer is choice 4. There's only one compound present. Choice 1 is an element. Choice 2 is a mixture of elements. Choice 3 is a mixture of compound. So the best answer is choice 4. In this check of understanding, here are some examples of Regent sphere response questions. Try to do these questions by yourself first. Resume the video once you complete it. Question 1. Which diagrams is showing an element and why? Diagram A and B because it's only one type of atom. Question 2. Which diagrams is showing a compound and why? Diagram C and D because a substance have 2 different atoms bonding. Question 3. How many particles are in each box? Let's count the particles in each box. In diagram A, there is 1, 2, 3, 4 particles. In diagram B, this counts as one particle. So it will be 1, 2, 3, 4, 5. In diagram C, this counts as one particle. So it will be 1, 2, 3. And diagram D, this counts as one particle. So 1, 2, 3. Question 4. Explain in terms of particles why the diagrams are showing a pure substance. On the Regents exam, whenever you see the word in terms of something, you have to mention that something in your answer. So in question 4, we have to mention the word particles somewhere in our answer. So the answer for question 4 is each diagram is showing only one type of particle. How will you describe this particle diagram? This is a mixture of elements. There is no touching between the 2 elements. How will you describe this particle diagram? This is a mixture of compounds. There is no touching between the two compounds. And how will you describe this particle diagram? This is a mixture of elements and compounds. This concludes the video lesson. Remember to do the Juniper homework.